Hey guys, Jared here, and today we're going to find out if paying extra for a second graphics card in your laptop is worth it. We'll perform some gaming benchmarks with and without a second graphics card in use, and find out how much extra performance Nvidia's SLI actually gives us in various games. Nvidia allows us to run multiple graphics cards together in order to get better performance. This feature is known as SLI, and is available in laptops. While this sounds great, SLI does have some drawbacks. SLI is not perfectly scalable. For instance, if you get 50 FPS in your favorite game, adding a second graphics card will not increase you up to 100 FPS. The real result will depend on many factors, including how well the game developers implemented multi-GPU support. Not only do you have to pay more for a second graphics card, which physically requires more space in your laptop, an additional card will increase power usage and heat output, as well as create extra noise due to the extra cooling. Not only will the additional graphics card also add additional weight to the laptop, but the additional cooling will also add further weight too. These various aspects need to be carefully considered in a laptop environment, as you only have as much power as the battery installed, unless you're always plugging in, or have a spare battery ready to go. In order to determine if the extra performance is actually worth it, I'll perform some benchmarks so we can get an idea of how the laptop performs with a single graphics card and with two in SLI. This particular laptop has dual Nvidia 1070s installed, and I've done a full review on it previously if you're interested. We'll start with some real-world gaming benchmarks, and then move on to some synthetic benchmark tests. The laptop also has an Intel 7700K desktop CPU. I've overclocked it to 4.9 GHz in order to help reduce the CPU as a potential limiting factor as much as I possibly could. For reference, I've also included the non-overclocked results as well. However, I didn't actually record the CPU maxing out at all during any of the tests anyway. Additionally, I also didn't experience any thermal throttling throughout my testing. In Grand Theft Auto 5, I've disabled VSync and tested with FXAA on and MSAA set to 8 with a 1080p resolution. With SLI disabled, we averaged 75 frames per second, and then with the CPU overclocked, this remained the same. With SLI enabled and the CPU back on stock speeds, we averaged 86 frames per second, and then with the CPU overclocked, this went up to 101 frames per second. In The Witcher 3, I used the Ultra preset, disabled VSync and Nvidia Hairworks, and again ran at the full 1080p resolution. With these settings and with SLI disabled, we averaged 78 frames per second. And then with the CPU overclocked, this actually dropped slightly to 77 frames per second. With SLI enabled, I was able to get an average of 108 frames per second with the CPU on stock speeds, and then with the CPU overclocked, this increased a little to 115 frames per second. In Shadow of Mordor with Ultra settings at 1080p, a single 1070 averaged 151 frames per second, and then 150 frames per second with the CPU overclocked. With SLI enabled, we averaged 169 frames per second, and this result did not change even with the CPU overclocked. From these tests, it appears that the difference with and without CPU overclocking with a single graphics card is basically the same. The differences are within the margin of error. However, it does appear to make a more noticeable difference with SLI enabled. I suspect that because with more graphics power available, the faster CPU may be of more use. It will also depend on other variables, such as how much does the particular game rely on the CPU. In my opinion, these real-world gaming benchmark tests that I've covered so far are what you should mostly consider, as they show how much practical difference you would actually expect with and without SLI. The synthetic benchmarking tools that I'll be using next aren't as useful as a practical indicator. In real games, adding a second graphics card doesn't scale perfectly, whereas in these synthetic tests, they're designed to perform very well with additional resources, making it appear that SLI is a larger boost than it really is, so take them with a grain of salt. In Heaven benchmark with the quality set to Ultra, tessellation set to Extreme, and anti-aliasing on 8 at 1080p, a single 1070 averaged 91 frames per second, and then 92 frames per second with the CPU overclocked. With SLI enabled, the single 1070 averaged 152 frames per second, and then with the CPU overclocked, this increased to 161 frames per second. In Valley benchmark with the quality set to Ultra and anti-aliasing on 8 at 1080p, a single 1070 averaged 90 frames per second, and this stayed exactly the same even with the CPU overclocked. With SLI enabled, both 1070s managed to average 112 frames per second, and then when we overclock the CPU, this increases to 123 frames per second. Next, I ran both the Firestrike and TimeSpy benchmarks from 3D Mark, and in Firestrike got a score of 14,546 with a single 1070, and a score of 21,207 with SLI enabled. Then with the CPU overclocked, I got a score of 14,590 with a single 1070, so a small improvement, and a score of 22,147 with SLI enabled, a slightly higher improvement in comparison. As for TimeSpy, I got a score of 5,384 with a single 1070, and a score of 9,082 with SLI enabled. With the CPU overclocked, the single card score increased slightly to 5,394, while the score with SLI enabled rose slightly to 9,129. Based on my results, without performing any CPU overclocking, on average having a second 1070 in SLI improved the average frame rate of the games tested by 17.2%, while the synthetic benchmarks saw an improvement of approximately 33%. With both types of results combined, we saw a 26.2% improvement on average over all tests with SLI enabled, with no CPU overclocking. As mentioned, overclocking the CPU did not appear to change things with a single 1070 in use. However, as we've seen with SLI enabled, we did actually see a small boost in all the results. With the 7700K overclocked to 4.9 GHz, we saw an average improvement with SLI enabled of 23.3% in the games tested, and an improvement of 36.2% in the synthetic tests. With these results combined together, we saw an overall improvement of 30.7% with SLI, while the CPU was overclocked. After considering the results of these tests, I find it pretty difficult to recommend getting a laptop with SLI, unless you really want the small extra increase in gaming performance. You may get a better bang for your buck by simply getting a better graphics card. For example, while this laptop has two 1070s, it also has the option of a single 1080, which is actually cheaper, and may perform better in various games. I can't actually say for sure, as I've not personally tested a 1080 yet. In general, getting a better graphics card instead of SLI is usually a better choice. With SLI, you're relying on the game developers having implemented multi-GPU support well in an efficient manner, which will vary based on each game. Essentially, the additional card just doesn't scale that well for me to think it's worth spending hundreds of dollars on. With that said, if the extra weight, heat, noise, and cost aren't issues and you're still interested, then by all means go for it. However, if these other factors matter to you, then you may need to think twice before buying an SLI-based laptop. Also, don't forget that if you're getting an SLI-based laptop, make sure that you pair it with a display capable of a higher refresh rate. A standard 60Hz panel, for instance, is probably not going to be a good idea if you actually want to be able to take advantage of those higher frame rates that you're paying for. So what do you guys think about getting SLI in a laptop? Is it something that you'd consider paying more for to get extra performance, or would you just get a more powerful single card? Be sure to let me know your thoughts down in the comments, and leave a like on the video if you found it useful. Thanks for watching, and don't forget to subscribe for future tech videos like this one.